Hi, my name is Dominic Garrity. I'm a student at the college studying computer science and economics and taking ES50. For my final project, I made a sound-reactive LED strip. To do so, I needed a microcontroller, in my case, an Arduino Uno, a sound detector, an addressable LED strip, mine was 1 meter, a 5-volt power supply, a 5-volt power port, a large breadboard, and a whole bunch of wires. Now, the device works in the following way. First, power is fed into the 5-volt power port via the 5-volt power supply. I ordered one off a SparkFun which plugs right into the wall. Note here that everything shares a common ground and that 5 volts is enough for the Arduino, the microphone, and the LED strip. Though the microphone has 4 total outputs, I only use 2, the gate and the audio. The gate is a digital signal, meaning that it's either 1 or 0, indicating whether or not the microphone detects sound. On the other hand, the audio is the actual analog signal that the microphone picks up. I feed both of these into the Arduino as inputs. Naturally, the gate goes into one of the digital pins, and the audio goes into one of the analog pins. Instead of using analog filters to obtain information on the signal's frequency, I wrote an Arduino sketch which employs the FFT package to compute its Fourier Transform. Effectively, this converted that analog sound from the time domain to the frequency domain, aggregating each constituent signal by its frequency and providing its amplitude. The sketch first detects whether or not the microphone is receiving any sound by reading the gate pin. If it is, it receives 32 samples from the microphone and thereby creates 16 frequency buckets, ranging from 0 to 20,000 Hz, into which the amplitudes of the constituent signals are placed. I used the loudest signal from each sampling period to determine how the LED strip would act. More specifically, if the loudest frequency of the sampling period was different from that of the previous sampling period, I changed the color of the strip by traversing an array of possible hard-coded colors. I also wanted the LED strip to appear as if it were pulsing to the beat of music. For this reason, I focused on the first bucket of the Fourier Transform, the one which contains signals between 0 and 1250 Hz. I established some small relative threshold, and if this bucket's amplitude change was greater than that threshold between sampling periods, I turned the LED strip off for 50 milliseconds to make it appear as if it were pulsing. This schematic here shows the final circuit. As we can see, this wasn't a very hardware-centric project. I was able to do most of the signal processing and analysis in software. And even though this went against my original plan, I think this ended up being the better approach. I was motivated to do this project because my roommate said we needed more flair in our room, and needless to say, this is going to be its real-world application. Early on, I spent a lot of time trying to filter and process the signals through hardware, and this was definitely the biggest challenge I faced. Ultimately, though, I was able to shift my approach and create a project that I'm super eager to use.